What's going on, everyone? I hope you all had an amazing and relaxing Labor Day yesterday and took some time off just to slow down and enjoy life. Today is the 189th episode of the ARC Junkies podcast. We just had the ARC Junkies 4th year anniversary on September 4th. What I'd like to do with this show, I want to do something a little bit different. I've been wanting to do an episode like this for quite a while, and I've pushed it back several times due to scheduling. And, what I'd like to do is, I get requests all the time about different welding applications, process selections, advantages and disadvantages of certain processes, equipment setup, and various other questions. So what I'd like to do is kind of go through the different processes a little bit more in depth, just kind of solo, and deliver in a little bit more of a structured way and drop some information to help out the welding community. Today I'm going to start off with the fundamentals of shielded metal arc welding, more commonly referred to as stick welding. And then in future episodes, I'd like to cover MIG welding, TIG welding, flux core, both self-shielded and gas shielded, and some of the various cutting processes as well. Just kind of take it back down to the basics, and then maybe drop some more advanced knowledge along the way. But before we get into today's episode, I'd like to take a moment to tell you about some of the different products available through the supporters of the show. Today's episode of the ARC Junkies podcast is brought to you by the Stepped Wedge. The Stepped Wedge was created by Jamison Burt, a triple-ticketed journeyman in pipe trades out of Canada. Jamison is the inventor and patent holder of the step and spatterproof wedges. He dedicated his life to manufacturing high-quality and innovative tools in the pipe welding industry. He knows pipe welding because he is a pipe welder, and he knows what it takes to get the job done. Stepped wedges are available in 3 different sizes, 4, 6, and 8 inch, so you can handle any gap on the print. The stepped wedges are incremental, so they can handle gaps all the way from 3/32 up to 1/4 of an inch. And for my friends across the pond, the stepped wedges are available in metric sizes as well. Each flat surface of the stepped wedge is machined to 5/1000 of an inch tolerance and made from hardened stainless steel so they won't contaminate your exotic alloys. The spatterproof wedge is plasma nitride carbon steel, making it nearly indestructible. Right now, Stepped Wedge has an awesome deal for listeners of the ARC Junkies podcast. When you place an order, you can get 10% off when you use the code word ARC Junkies in the discount box at checkout. Head on over to gapandtack.com right now to take advantage of this great deal. That's gapandtack.com. Wedges made for professionals. We're also brought to you by Fronius USA, and right now they're running their Dip into Summer promo where you can get a $600 rebate when you buy a Magic Wave 230i in either air-cooled or water-cooled, along with a Bluetooth accessory. You can choose from the Visor Connect welding helmet or the wireless foot pedal. The Fronius Magic Wave 230i AC/DC air-cooled TIG machine is another huge step forward in the welding industry. Fronius brings their state-of-the-art welding technology to a brand new AC/DC air-cooled TIG welder. Every time Fronius comes out with a new machine, a new standard is set and the world of welding takes a huge technological leap forward. This machine is no exception to that, and we know you'll be impressed. The Dip into Summer sales promo is only available until September 30th, so you have time to take advantage of this awesome deal. We're also brought to you by Rockmount Research and Alloys. You can check them out at rockmountwelding.com. And if you're not familiar with their products, check out episode 149 of the ARC Junkies podcast, where I sit down and chat with Pat Adams, who's a wealth of knowledge when it comes to maintenance welding. Rockmount makes electrodes and wires made for the real world. After the equipment has left the manufacturer and it's installed in the factory, or it's out in the field and it breaks down, Rockmount has the electrodes to get you back up and running. We all know downtime costs more than maintenance, so get the job done right the first time with Rockmount Welding. Rockmount recently teamed up with MSC to make it even easier to get their products right to your shop or your front door. Head on over to mscdirect.com and get your Rockmount products and take advantage of their free shipping on all Rockmount products. We're also brought to you by Everlast Welders. Whether you're new to welding or you're a seasoned professional, Everlast has the perfect machine for your skill level and budget. Whether you need to be able to stick, MIG, TIG, or even plasma cut, Everlast has you covered. Or maybe you're looking for a multi-process machine to do a little bit of everything. That's fine, they have those too. And now is a great time to pick up an Everlast machine to start that side hustle or small business in your garage or home shop. I personally use the Everlast myself, and that's why I recommend it. I'm currently running the 255 EXT for all my TIG jobs and the Cyclone 200E for all of my MIG jobs. Both machines perform great. My favorite part about these machines is the 5-year warranty. Where else can you get a machine at this price point with this type of performance and that kind of warranty? And right now, if you buy any machine that comes with a stock foot pedal, you can use code word ARC Junkies in the comment section at checkout and get a free Nova foot pedal and TIG torch. That's a $100 value. All right, ladies and gentlemen, you know what time it is. Fire your machine, drop your hoods, and turn me up 5.
You're listening to the ARC Junkies podcast. Helping you make every weld better than your last with each episode. And now your host, Jason Becker.
All right, everybody. So in today's show, we're going to talk all about shielded metal arc welding. It's often referred to as stick welding or simply arc welding. These terms are pretty much used interchangeably in the welding community. So if somebody's talking about stick welding or arc welding, they're obviously talking about shielded metal arc welding, which is based off AWS's standard terms and definitions. That's what it's referred to. So you'll never see stick welding or arc welding on a welding procedure specification. It's going to be shielded metal arc welding, or SMAW. It's probably my favorite process because, like I tell all my students, it's the hardest process to learn, but once you learn how to stick weld, you can learn any of the other processes pretty quickly. So I always start them off with stick welding because it's a challenge. It's going to teach you patience. It's going to teach you all the fundamentals that you need to know that are going to transfer into the other processes, like travel speed and work angle and, identifying the puddle and manipulating the puddle. All that good stuff. So if you can make it through stick welding, if you can learn how to do that proficiently, you can learn all the other processes pretty quick. Stick welding is probably one of the oldest forms of modern welding anyway. This is the one that they came out with way back in the day, putting the ships together and stuff like that, and, started migrating away from riveting. They were using stick welding on a lot of these different projects. It's the most common application for welding in the field because it's highly portable. Now, when we talk about shielded metal arc welding, this process can be used with alternating current or direct current, and it produces a nearly constant current, meaning the amperage is going to fluctuate very little, but voltage can fluctuate quite a bit. And both of these variables are impacted by arc length, or how close we're going to hold the electrode or the welding rod to the puddle. One thing I always like to start my class off with are the advantages and disadvantages, because that's a lot of the questions I get on Instagram. Hey, when would I use this specific welding process over another welding process? Obviously, what equipment you have access to is going to dictate what you're going to use, but I always like to cover advantages and disadvantages, because sometimes there's a better welding process we can use for a certain application. So some of the advantages of stick welding: it's highly portable, especially if you have like an engine drive, or, if you have like a regular buzz box at the house. They're highly portable. It's a typically lightweight equipment. You can move around pretty easily. Like when I worked out in the field, it's a lot easier to take an engine drive welder and set it up on top of the roof than it is to get like a transformer rectifier or an inverter to bring that up there and then run power to it. You got everything you need right there. You just fire the machine up. Another one of the advantages: you can use it outdoors in windy applications. So like when we talk about different welding processes, that's a big feature, right? Because we don't have to rely on an external gas tank. So I don't have to take a cylinder, a high pressured cylinder, up with me to where I'm going to be doing my welding, especially if I'm doing field applications. All I have to do is hook the stick electrode up to it and I'm good to go. Don't have to worry about external shielding gas because the stick is going to create its own. Whereas if I was to use gas metal arc welding, or MIG, or gas tungsten TIG welding, if I use those outside, I have to set up barriers and blocks and all that to keep the wind away from my weld puddle so I don't get contaminated. Another advantage is it's very simple to set up. I really don't need a whole lot to get this thing up and going, so it's very simple to set up. There's limited parts and accessories, and it's relatively cost effective for the type of welding that we're going to be doing with it. And it produces good weld appearance, and it's suitable for out of position welding. Meaning, depending on the electrode that I'm using, anything with a designation, like, so let's say for instance we have 7018, that third digit is a 1. 1 means that I can weld in any position: flat, vertical, horizontal, overhead, whatever. If I have a number 2 in that designation, that's meant for flat and horizontal fillet welds, and flat groove welds. So we want to make sure we're using the appropriate electrode for that situation, but based on the electrode, I can get out of position if I need to. It's some of the disadvantages of shielded metal arc welding. It's slower than other processes. So compared to like your MIG and your flux cores, it's much slower. So when we talk about shielded metal arc welding, we're looking at a deposition rate of 5 to 7 pounds per hour. So that's actually weld metal. So if I welded for a continuous hour and just welded, I'm not talking about taking the time to chip the slag off, wire brush it, inspect it, and all that stuff. If I was just putting rod into the stinger and just running wide open for an hour, I'm probably only going to put about 5 to 7 pounds of weld metal down. Now, that's not a whole lot, so that's why it's used out in the field, because we're not talking about high production welding. If I was in a manufacturing setting in a shop somewhere, obviously I'm going to switch processes to increase my weld deposition so I can lay more weld down and get more parts out the door. Another disadvantage is the electrode efficiency is only 60%, meaning, only 60% of that electrode that I'm using is going to be converted into weld metal. The rest is going to be lost to spatter and then slag and all that other stuff and smoke, because it's going to create its own shielding gas, so when that flux burns up, it's going to convert into CO2. So I'm losing, 40% of my electrode just in slag, gas, and possibly a little bit of weld spatter if I don't have my settings dialed in correctly. So that means for every 100 pounds of rods that I'm buying, I'm only getting 60 pounds per 100 pounds that I'm buying of weld metal. Some of the electrodes require special storage. So when we talk about our low hydrogen electrodes, those have to be, once we take them out of the can should be hermetically sealed or, airtight or something like that. Once we take it out of the can, it needs to go directly into a rod oven. So there's some special storage requirements when we talk about some of the electrodes with shielded metal arc welding. And it requires frequent starts and stops. So for a 14-inch long electrode, I'm only going to get 6 inches of deposited weld. And then I got to stop it. I got to chip, wire brush, clean it, make sure everything's good. And then I'm going to restart. So there's frequent starts and stop with this. So that's another disadvantage. Whereas if I was using like flux core or regular gas metal arc welding, I wouldn't have to stop. I'm only limited to the amount of wire that's on my spool and the amount of gas that's in my tank. Let's see. So we want to talk about some of the safety things up front. Obviously, anytime we're dealing with any welding equipment, we want to make sure that our clothes and our gloves are extremely dry. The equipment's dry. Funny story. I was kind of new to welding. It's way back, probably 2006 or so, 2007. I decided, I was going to go up on the bar joist and weld out some, bar joists. And I was putting in bridging at the time. And it was first thing in the morning. It's summer. It's Florida, so it's humid. Everything is just damp, moist, wet. So I climb up on a bar joist and I sit down, and now my pants are wet, not thinking about it, because I climbed up on top of everything using my gloves. Now my gloves are wet. I've got my stinger on my shoulder. I reach into my electrode pouch, grab a rod out, and go to throw up my stinger and complete that electrical circuit, and just literally shocked my ass. So I unplugged it and I was like, damn, that's not cool. And it's because my clothing was wet at the time. So you want to make sure that you're dry. You don't want to become part of that electrical circuit. So make sure your equipment's dry, your gloves are dry. You don't want to shock yourself while you're up there, especially on like ladder, bar joists. It was pretty stupid of me. So learn from my mistakes. Make sure all your equipment is dry. Another thing, we want to keep our hands away from the internal workings of welding equipment. A lot of times when we troubleshoot, we got to open up the side panel of that machine or mess around with the terminals. Make sure that machine is turned off and unplugged. And if you're using an engine drive, make sure you shut it off. Once again, you don't want to become part of that electrical circuit. Another thing, you want to make sure all your cords and cables are serviceable, meaning that they're free from cuts and bare exposed wire leads and all that stuff. Especially if you're working on job sites, but you don't want arc strikes. So if you're, dragging your lead across the floor and, you're up on some decking or bar joists or I-beams or anything like that, and you drag a bare spot across the beam or the decking, whatever the case may be, and it's part of that electrical circuit, you're going to complete that electrical circuit, you're going to get arc strikes and everything. And once the inspector sees that, you're probably going to have to repair or replace that member. So make sure, as you're taking, unpacking everything for the day, getting everything laid out for the morning or, whatever you're going to be doing for work, check over your cables, check over your leads, make sure everything's serviceable, that there's no bare or exposed leads or wires or anything like that. Plus, you're going to help reduce your risk of electrical shock as well. And then once again, ensure your machines are unplugged or shut off while you're working on or near the welding terminal. So whatever you're going to connect your workpiece clamp or your stinger, make sure your machine's off when you're doing all that stuff. You don't want to connect those two pieces together, especially if you're in there with your spud wrench or crescent or whatever you're trying to tighten down your lugs or anything like that. And you make contact between the positive and negative terminal, you're going to get lit up. So it's best not to do that. Some other things we want to consider, shielded metal arc welding, just like any other type of process, it's 10 times brighter than the sun. That's why you can't look at it, right? That's why we need to use a welding hood. So one thing you want to do is make sure you're using the right shade of filter lens with your welding hood. Now you can download the AWS ANSI Z49.1, and it tells you in that manual exactly what shield or what shade you should be wearing, what filter shade you should be wearing based on the process and the amount of amperage that you're running. So for most applications with shielded metal arc welding or stick welding, I run a 10 to 12 filter because that's what's recommended. You hear the old stories about, oh yeah, you know, so-and-so's grandfather was a welder. He did it for 20 years. And now he's blind and he's got cataracts and all this other stuff. And I mean, if you take the time to work safely and adhere to, you know, the common practices, you're not going to go blind. I've been welding for over 24 years. I still have 20/20 vision. Everything's good because I'm using the appropriate shade for the work at hand. You know, so don't be running like a number 6 or a number 7 just to get the job done, or, you know, you don't have enough money to go out and get a new lens. Wait till you got that new lens, you know. Run a 10 to 12 for any time that you're running stick welding. Refer to the Z49.1 once you get out at different applications. I know some of the welding hood manufacturers, they actually take the time to put a sticker on the inside of the welding hood that tells you exactly what shade filter you should be running based off the Z49.1. So check inside your welding hood. You might have a little chart there, you know, so when you switch over to flux core, that's another thing, man. I probably run shade 13 or 14 in there. Just make sure you're falling within those parameters. You want to protect yourself because you're going to be doing this type of work for a while. Again, cover any exposed areas to avoid burns from the extreme light. So we don't just have to worry about weld spatter and hot slag, you know, hitting our skin. Once you strike that arc, it's 10 times brighter than the sun. So yes, you can get skin cancer from welding if you don't cover up your exposed skin. I've told this story several times on the podcast. I worked with a guy and it looked like, you know, he got his arm caught up in a wood chipper, and I asked him like, hey, you mind if I ask, you know, what happened to your arm? He said, oh yeah, those are all the spots where I had melanoma pulled out because for the longest time I welded without sleeves when I was young and welding in a production setting. It was just, you know, it was really hot, you know, so I didn't put sleeves or a jacket on, and now I'm paying the price for it now. And he's got to go back every 6 months and they look over his skin, see if he's got anything else forming. If he does, they cut another chunk out. So, you know, protect yourself. Cover up any exposed skin, not just for sparks and spatter, but the ultraviolet rays as well. You know, those are not your friend. So you don't have to be the cool guy and, you know, weld without a jacket or weld without sleeves. You know, you're not really impressing anybody. You're just sacrificing your health. So cover up. And then do your best to protect others from exposing them to the bright lights as well. You know, so set up welding curtains, set up barriers in between you. Obviously, you're on a job site, you're up working the steel and stuff like that. You're not going to set any of that stuff up. People just know better than to look at the arc. But if you're in a shop environment and you got another trade working next to you, you're out in the field somewhere, set up a fire blanket, you know, just or a weld screen or anything like that to keep a visual barrier between those passing by or working in that area and your electrical arc. Moving on, let's talk about the different components of the shield metal arc welding process. This is, again, this is one of the advantages because I don't need a whole lot. I need a power source, whether it's the welding machine inside the shop and plug it into an outlet or an engine drive. So I'm going to need a power source, obviously going to need the welding machine. Then we're going to need an electrode holder. So that's the piece that's going to hold the electrode or the stick, as it's commonly referred to. Next thing I'm going to need is a workpiece clamp. A lot of people refer to this as a ground clamp. Technically, it's not really a ground clamp because we're not grounding to anything. That clamp just helps complete the electrical circuit. So we're not grounding to anything. We're just completing the electrical circuit. Then we're going to need some cables and leads and a workpiece, you know, something to weld on. And then the last thing we're going to need is an electrode. Obviously, we're going to need a welding rod, right? So very simple, very basic stuff. I don't need a whole lot of different consumables with this stuff. You know, we're not talking about gas and regulators and hoses and all this other stuff. It's probably the most simplistic form of welding, and that's one of the reasons I like it. I don't need to go out and buy a whole lot. I don't need to have to make a major investment in a bunch of accessories and consumables to do this. Just very basic, simple stuff. I want to talk about welding current a little bit. So during the shielded metal arc welding process, once the arc is initiated, the current is going to jump across a gap from the tip of the electrode to the surface of the workpiece. This is called our arc gap. During that process, the base metal and the electrode are going to mix together to form the weld. We also call that admixture. So you want to be as we're welding, there's a couple different things that are going on. We're melting the base metal. We're getting it into a liquid state. The electrode is also melting. Those parts are mixing together. So your weld is actually made up of base metal and weld metal. And then once it solidifies, now we have our weld, right? So that's one of the things we're going to talk about when we get into travel speed. This electrode is actually doing a lot of jobs at once, and we got to give it time to do that. One thing we never want to do is leave an electrode in the electrode holder or the stinger. We don't want to leave that in there and just hang it up on lean it on the side of the welding machine, or hang it off the workbench that we're working on, or hang it on the beam that we're on. Take that stick electrode out if we're not welding with it. It could cause fires if it connects to a piece of metal that's part of the circuit. It could cause damage to your welding machine. If it's just continuously kind of running that arc through and it's not making a weld, you can jack up your machine that way. And also, if you're on a job site, that could lead to a fine from OSHA from anywhere from $5,000 to $10,000, which, depending on your employer or, the OSHA guy, the inspector coming out there, you could be held financially responsible for that. So just be careful with that. Make sure you take the electrode out of the stinger anytime that you're not using it. I know it's a tough habit to break, but if you can just get into that habit of, once you complete that weld or once you do that tack, go ahead, take that electrode out, and then set the electrode holder up on something that's not connected to that welding circuit. Now I want to talk about the different types of current, because most people, they pretty much just weld on one polarity, and they don't know that you can weld on other polarities. Now, it's going to be very specific depending on the type of electrode or welding rod that you're using. But with shielded metal arc welding, we have a couple different choices to choose from. We can run electrode positive, we can run electrode negative, and we can run alternating current, which has no polarity because it bounces back and forth between negative to positive. So we're going to go ahead and talk about straight polarity first. It's probably the least common current and polarity with shielded metal arc welding. So straight polarity is also known as DC negative, or direct current electrode negative. The abbreviation for that is DCEN, or DCSP, meaning direct current straight polarity. Now, why is this important? Every manufacturer is going to label this a different way. You're either going to have a sign or a picture or a negative sign on that terminal, or in the welding procedure, it's going to say, DCEN. So that's, direct current electrode negative. So when we have this, when we're setting everything up, we got to make sure that we have the right polarity. With DCEN, there are some rods that run strictly on straight polarity, 6022 being one of them. What this is going to do is going to produce a wide bead profile and shallow penetration, right? So this is a perfect application, or the perfect polarity for a 6022 rod, because with 6022, I'm welding through a piece of sheet metal and tying it into a structural member, like an I-beam or a bar joist or anything like that. So I want a wide puddle. I don't want a whole lot of penetration because I'm blowing through that sheet metal, and to form that weld pool so that sheet metal doesn't pop off. With straight polarity, 70% of the amperage or the heat is going to be placed on the base metal. The other 30% of the amperage is on the electrode. Okay, that's why we're getting very shallow penetration. So when we set this up, we're actually going to hook up our stinger or our electrode holder to the negative terminal, and our workpiece clamp to the positive terminal, because in a welding circuit, our amperage is going to flow from negative to positive all the time. We can't change that. Okay, so when we hook it up, electrons are going to flow from the negative terminal to the positive. So think about kind of like an electrical circuit. It's going to come out of the negative terminal, run all the way up through the stinger, down to the electrode, hit the base metal, to the workpiece clamp, and then back to that positive side. Now, inversely, the opposite side of that is DC reverse polarity. That's probably the most widely used. That's pretty much what everybody runs, because we're running 6010, 7018. I mean, those are the two most common electrodes that everybody's going to be using. You're going to run that on DC positive, okay? And a couple terms for that is obviously DC positive, so you're going to see DC with the plus symbol, but then you're going to also see DCEP for direct current electrode positive, or DCRP, this direct current reverse polarity. So anytime we talk about reverse polarity, that's pretty much what everybody's familiar with, meaning your electrode holder is on the positive and your workpiece clamp is on the negative. Now, in this configuration, 70% of the amperage, or your heat, is going to be on the electrode. The other 30% of the amperage is going to be on the base metal. This is going to allow us to get much deeper penetration. Okay. And then the last process, or the last way we can configure this, is AC. So some of the old Lincoln Tombstone machines, they only run on AC. Now, can I still run a 7018 on one of these? Yes, I can, because what they figured back in the day is most home hobbyists are running AC machines, and we want them to be able to run 7018. So if we add potassium to this welding rod, we add potassium in the flux, it's going to allow that electrical current to switch back and forth between positive and negative, right? Because AC has no polarity association. It's actually alternating back and forth. And in the United States, it's switching back and forth about 60 times a second between negative and positive. And to keep that arc initiated at all times, as it transfers from negative to positive, they added the potassium to it to help it be able to achieve that. In one complete cycle, this wave is going to cross across the axis twice. So now 50% of your heat is on the electrode. The other 50% of the heat is on the base metal. That's not something we typically use in the U.S. unless we have to. So like if you have limited resources, you can weld on AC. Now I have heard of people running an AC route to prevent arc blow, when they're doing test plates, but you need to make sure that it's written in the weld performance specification or the weld procedure specification before you do that. Don't just go switching your machine over to AC, because you're going to get shallower penetration. So make sure you're adhering to the welding procedure spec. If you're at the house, you're just welding something together, you should be fine. I just wouldn't do a whole lot of things structural with it. If you do, you're gonna have to bump your amperage up, quite a bit to kind of make up for that loss in current, because now 50% is on the base metal, 50% is on the electrode. All right, we're gonna go ahead and take a quick commercial break. This segment of the Arc Junkies podcast is brought to you by Strong Hand Tools, makers of heavy-duty welding tables, toggle clamps, magnets, and fabrication tools. If you're a welding student and you want to register your school for a free gift, head on over to stronghandtools.com/ArcJunkies to register, and be sure to visit them at FabTech 2020, booth number 35026. They'll be there from September 13th to the 16th. We're also brought to you by AHP Welders, the perfect machine to get into welding. You can get a great machine for under $1,000 right now and start your journey into welding, and finally put all those skills you're learning on YouTube into a practical application. Check out ahpwelds.com and find the best machine for you. I've used these machines myself, and they perform great for the price point. That's ahpwelds.com. Now let's get back into the show. So let's go ahead and talk about the different welding variables in technique. So some of the different techniques are, some of the things we want to pay attention to as we're performing stick welding or arc welding. Travel angle is going to be a big one. Work angle, travel speed, and arc length. These are the things you want to keep in the back of your head. So travel angle, work angle, travel speed, and arc length. You're going to be able to alleviate a lot of weld discontinuities just based off these four different things that you want to consider while you're welding. The biggest one's probably going to be your travel angle. Now, we know that, anytime we're using a process that produces slag, so we're going to want to drag that. So there's an old adage: if there's slag, you drag; if there's gas, you push. So anytime I'm using something that produces slag, so for instance, shielded metal arc welding, obviously, we get into flux cord arc welding. That's another process where I'm going to want to drag, and then even gas shielded flux core, I'm going to drag that as well. Even though it has gas, that slag is going to supersede that. So I'm always going to drag any process that produces slag. Now, when I do this with shielded metal arc welding, I want to have roughly a 20 to 30 degree travel angle. So I'm going to lean in the direction of travel. So if I'm right-handed, I'm welding from left to right. And if I'm left-handed, I'm welding right to left. So I'm just, for the instance of this, because I'm right-handed, I'm going to go left to right because I'm right-handed. You want to make sure you hold that electrode at a 20 to 30 degree angle. Now, if I'm straight, that's from straight up and down. If I'm straight up and down, I'm probably might trap a little bit of slag in that weld puddle. And I'm also probably going to get some weld spatter as I'm going through. Because I'm just splashing right into that weld pool. So I'm going to lean it back 20 to 30 degrees toward the direction that I'm traveling. And what that's going to do is that's going to help me get the best penetration out of that weld, keep a lot of the weld spatter out, and just make sure that I get a good weld. The next one is the work angle. So if I'm welding on like flat plate or something like that, or I'm doing like a butt weld on flat plate, my work angle is going to be 90 degrees perpendicular to the horizontal plane of the piece that I'm working on. So you want that rod straight up and down, and then you're going to tilt it, 20 to 30 degrees towards the direction of travel. Once we get into like a fillet weld, so like if we have a T-joint or anything like that, the most common weld you're going to produce out in the field is most likely going to be a fillet weld. What you want to do is bisect that joint with the weld angle. So if I have a 90-degree angle, I'm going to hold that work angle at 45 degrees, right in the center of both, because I want half of that weld metal to land on the vertical part of that fillet weld and the other half to land on the horizontal member. So I want to split the difference between the vertical and the horizontal member. So I want equal weld on both sides of that plate. So if I hold that electrode at a 45 degree work angle, 20 to 30 degree travel angle, and just kind of smoothly go along that piece, you're going to be all set. I'll get 50% on both members. Now, if we have to do multi-pass welds, we always want to start from the bottom and work our way up. So after you get that initial root in, I'm going to point right at the toe of the previous weld. So, pass number 1, moving on to pass number 2, I'm going to point on the bottom toe of pass number 1, and I'm going to start there, and I'm going to maintain roughly a 30-degree angle on this one, work angle, 30-degree work angle, and then roughly a 20 to 30-degree travel angle. So as I'm going through that joint, my objective with this is to cover that first weld up roughly 50 to 70%. Okay, I still should be able to see a little bit of weld number 1 when I do this. Now, likewise, when I go up to do pass number 3, I'm going to point right at the top toe of pass number 2, right? So now I'm working my way up. It's kind of like building a set of stairs. We're going to start at the bottom and work our way up. That top pass should cover up 50% of weld number 2 and 100% of weld number 1. So I should never see pass number 1 ever again after I put my second pass in. That's going to be roughly a 70-degree angle from that plate that we're working on. And you're just going to have to experiment with those a little bit. I know it's kind of hard to kind of envision that in an audio format versus, a visual format, because most welders are visual people. They got to be able to see it. But, use those different angles. Remember, you put the first pass in, 45-degree angle, just kind of bisect that second pass at that 30-degree angle. And what you're trying to achieve is 50 to 70% coverage on pass number 1. And then pass number 3, you should cover up 50% of pass number 2 and all of pass number 1. Okay, and what we're trying to achieve is that 45-degree angle. So if you look at the end of that fillet weld, 50% of the weld should still be on the vertical leg, 50% should still be on the horizontal leg, and you're just going to continue on that path until you get the desired weld size. Now let's go ahead and move into travel speed. Travel speed is always tricky for people, especially those new to welding. Once you get into welding, they just want to get in there, they want to go fast. But as I said earlier, that rod's doing a couple different things. We're melting the base metal, we're melting the electrode. Those two metals are mixing, and then it's solidifying. So it's doing 4 jobs. We got to give it time to do its job. Now, the typical travel speed for shielded metal arc welding, most shielded metal arc welding, and it's roughly 3 to 6 inches per minute. So one thing that I go through and teach my students is, I'll grab a 6-inch plate, and then I'll scribe or, grind little marks in there every inch. So if I have a 6-inch plate, I divide it up into 6 equal spaces, so that's 5 lines. I tell them to start on, depending on right or left hand, so we'll go with right-handed for this case. Start on the left-hand side. You're going to strike the arc. Get that puddle established first. It's like your MasterCard. You don't leave home without it. And just do a slow, steady pull. And you should be hitting each one of those 1-inch marks right about the 10-second mark. So as you start welding, you just count in your head. 1, 2, 3, up until the time you get to 10 in your head. And once you hit 10, you should be crossing one of those lines, right? And that'll give you roughly the perfect travel speed. Now, if you're getting to that mark after 10 seconds, you're going too slow. If you get to that 1-inch mark around 4 or 5 seconds, you're probably going twice as fast as you need to. So you got to slow down. Faster travel speeds, they're going to result in a high ropey bead profile with little to no penetration. So if you're welding along and you look at your pass, you're like, damn, it's high, it's ropey, it's not really tied into anything. That's a good indication that you went too fast and you need to slow down. Now, likewise, slower travel speeds are going to result in more metal deposits. You're going to have a much wider weld than you were anticipating. You're going to get a lot more spatter, and you're just going to have a weird looking bead, right? So it's not going to be the bead appearance that you're looking for. So you want a nice smooth profile the whole way. The weld should be roughly 1.5 times the diameter of the electrode that you're using. So if you're using an 1/8 inch 7018, you're probably going to be right around 3/16 of a 1/4 inch wide. Any wider than that, you're probably going too slow. So try using that that method where you just mark everything out, and like, if you're doing weld production, you can put it in there with a soapstone. You should be able to see it just a little bit. Or if you're just doing practice, take a cutoff wheel and just make some marks on a plate, space them out 1 inch, and just do that little counting in your head. That's going to help keep you on track. The next biggest thing, arc length. Okay. I see too many times people have excessive arc length. You want to keep a nice tight arc length anytime you're performing shielded metal arc welding. So the arc length is going to be the gap between the tip of the electrode and the base metal. So a good rule of thumb is your arc gap or arc length shouldn't be any bigger than the diameter of your electrode. So if I'm running a 7018 1/8 inch diameter or 6010 1/8 inch diameter, I don't want to be any further than an 1/8 inch away. Okay, if I get too far away, what's going to happen? Voltage is going to increase, amperage is going to decrease slightly. I'm going to start getting spatter in my weld pool. The weld's going to get much wider than I want. And it's going to, especially if we get out of position, we don't have a tight enough arc length, I'm just going to start dropping metal everywhere. There's going to be little droplets coming off the rod. If you have little droplets coming off and falling into the puddle, you're too far out. And you should be able to, once you get into the habit, once you get better at stick welding, you're going to be able to identify it by sound. I can walk through my welding shop and tell you whose arc length is too far out and who's, right where they need to be. Another indication is, anytime you see somebody running stick welding, if you're in a shop or out in the, outside, watch that voltage. That voltage is going to jump all over the place. And if they're holding a consistent arc, that voltage, the voltage is going to jump all over the place. But if they're holding a consistent arc, amperage is going to be nearly constant. Now I can look at a machine in my shop on the digital readout and tell you if somebody's arc length is too far out, because that voltage is going to increase, and I'm going to be able to see the amperage drop a little bit. So I know most of my students, depending on the position we're working in, I know roughly what amperage they should be at. So if it's fluctuating, if it's dropping lower than what they should have it set for, I know that their arc length is too far back, and I can walk into the booth and say, hey, you need to tighten up your arc length, and here's why. And just kind of walk them through that process. One of the things I like to tell my students is we use an acronym, CLAMS, right? CLAMS. It stands for current setting, length of the arc, angle of electrode, manipulation of the electrode, and speed of travel. So if you keep that in your head, and I got some of my students, they'll actually write CLAMS up on the on the inside of their booth when we're going through the welding procedure, and they're just now learning. So current is going to be a big thing. You want to make sure that your amperage is set based off of what's recommended for that welding rod that you're going to be using. So I've said this time and time again on different episodes of the podcast. Everybody has a smartphone, and you can download consumable books from whatever manufacturer. So whether it's Lincoln, whether you got Hobart rods, or whether you have ESAB rods, you can get a PDF download version of all the electrodes and all the wires and consumables and everything that they have. And it's going to tell you exactly how to set your machine up to run that diameter of electrode, based off the type of electrode that you're using. So a good rule of thumb with all of your low hydrogen electrodes is to use the decimal equivalent. So like for instance, Lincoln says that I can run a 7018 1/8 inch diameter Excalibur at roughly 90 to 160 amps. Okay, that's good. Now I've got a window to work with. But a good rule of thumb is if I take the decimal equivalent of that electrode, it's going to get me really close to where I need to be in the flat position. So if we take an 1/8 inch, we convert that to a decimal. We do that very easily by taking 1 divided by 8, so numerator divided by the denominator. That's going to give me 0.125. So that tells me that I need to run in the flat position roughly 125 amps. It's just a good place to be. Is that the gospel? No. Set your machine to 125, strike an arc, see how it welds. If you need to bump it up, you can always bump it up to at least 160 before we start getting out of the realm of, what the manufacturer says I need to be at. And I can run it down to as low as 90. But I've found in my experience that 125 amps works pretty good. Now, people are going to call BS and say, no, I run mine at like 145. Oh, well, you probably do. But one thing you have to consider is if I'm running a machine at my house and I only have about 10 foot of lead between my workpiece clamp and my electrode lead, 125 amps is exactly what I'm getting. But for every 50 foot of cable that I run out, whether it's on negative or the positive side, for every 50 foot of cable that I run out, for like engine drive applications, I need to add 5 amps because there's going to be roughly a 5 amp drop. So if I add 50 foot of lead to my positive and 50 foot of lead to my negative, I need to now bump up my amperage to, 10 additional amps, because now I have a 10 amp drop because I'm losing 5 amps for every 50 foot that I'm putting out. So now if I want to, hook that much lead up, 50 foot on each side, I need to bump my machine up to 135. That way I get 125 amps where I'm welding. So you're going to have to play around with this. You're going to have to see exactly, what you're getting. And if you don't have a clamp-on multimeter, you're going to have to do it by feel, or, it's just going to come naturally to you, or, have somebody set your amperage while they're at the machine. That's where that whole, turn me up 5 comes from. That's typically on the job site. You're going to say, hey, turn me up 5 or turn me down 5. You're going to do it in 5 amp increments roughly. So make sure, you get dialed in for the correct process, the correct amperage that you need for, what you're welding on. And it's not based off of the thickness of the material, right? I'm basing this off of the thickness of the rod that I'm using, because obviously if I'm welding a 1/4 inch plate, for a single pass, I'd need roughly 250 amps to do that in a single pass. I'm not going to do that with an 1/8 inch rod, right? I'm going to have to do that probably a multi-pass. I might put 2 passes down on there, 3 passes. I know for 3/8 plate, I'm going to throw, roughly a 3 bead stringer on there. So you're going to base the amperage off of the electrode that you're using, not the thickness of the material. The number of passes is going to be based off the thickness of the material to hit that desired weld size. So moving on with clams, the next one is the length of the arc. We talked about that. Make sure to keep a nice tight arc length. If that arc length is too far out, you're going to get an erratic puddle. That's where, once you start getting towards the top, if you're doing vertical, if you don't have a nice tight arc length, chances are you're going to get a little bit of arc blow in there. So make sure you keep that nice and tight. The A, again, is the angle of the electrode. So remember, we have 2 different angles that we're dealing with. We're dealing with our work angle and our electrode angle. Or, I'm sorry, travel angle. So work angle and travel angle. So as we're going up, or, across the plate or whatever, make sure, you're hitting the appropriate angle to place that bead exactly where you want it. And then that travel angle. Travel angle is going to be extremely important, especially when we start getting out of position. I've got roughly a 5 to 10 degree angle when I'm going vertical. So I'm just going to drop the back end of that rod down about 1 inch lower than the tip. So angle is important. If your angle's too steep, you're not going to get the desired results. You're not going to get the penetration that you need. So remember to keep those, the different angles. Pay attention to those as you're welding, because it's very simple to get off track. One thing I like to tell people is, keep your arms close into your body. It's going to keep you stable. And you're going to be able to maintain those angles a lot better. Next up is manipulation of the electrode. So 7018, 7024, 7028, 8018, all of these are considered drag rods. So there's not a whole lot of manipulation you need to do. However, you need to be able to read your puddle. So if your puddle needs to be a little bit wider, you need to slow down. You might have to oscillate or just manipulate a little bit. And I'm not talking about, throwing big old weaves on things. I'm just saying you might have to bounce that electrode up or down just a little bit to make sure you're wetting into the toes and covering up the appropriate amount of the previous pass that you're welding on. So pay attention to the manipulation of your electrode. One thing, I was talking to Travis Fields about this a little while ago. He has a video on YouTube that he did for WeldTube on using a metronome to walk the cup. Well, I kind of adopted that same thing and found out that for me, my manipulation when I'm doing vertical and overhead, because I have a slight oscillation, is roughly 60 beats per second. I downloaded a metronome app on my phone, and I just kind of messed with that as I was welding, and I found out it's about 60 beats per minute. So one thing I like to tell my students is, hey, what kind of music you listen to? Whether it's rock, hip hop, R&B, whatever, you can type in rock music, 60 beats per second, or country music, 60 beats per second into Google, and it'll give you an entire playlist of music that's 60 beats per second. So you can actually start timing your welds out. Welding's all about rhythm and technique and figuring that out. And that's why it took me so long to learn how to do stick welding, because I've got no rhythm. I have no rhythm whatsoever. But I've noticed that if I, put in a set of headphones and I've got music playing right around 60 beats per second, my welds would turn out a lot better. So, just time yourself. You want to be consistent with this, and having that little beat in your head helps you stay consistent. Likewise with a 60-10, when you're doing your little whip and pause action, you're getting into a tempo. You've got a rhythm going. You've got a 1-2 count, and then you're going to whip out 3/8 to a 1/2 inch, and then you're going to tie back to that previous puddle. You get into a little rhythm. 1-2, 1-2, 1-2, and you're going to whip out. So manipulation of the electrode is going to be key, and you're going to have to find out what that manipulation is for you, that manipulation and timing. The music is also going to help with the last one, S, speed of travel, or our travel speed. So as we go through there, if we have a little song in our head, we're not going to get too far too fast. You remember, you want to keep it right around 10 seconds per inch. So travel speed is going to be a big key. So remember, if we have a high ropey bead profile, we're going way too fast. We got to give that electrode time to do what it needs. Likewise, if the bead's way too wide, we got a lot of excess spatter in there, maybe a little bit of overlap. We might want to speed up just a little bit. So, always, once you get done with your weld, chip it, wire brush it, and think to yourself, how can I make this weld better? What went right? What went wrong? And what can I do to fix anything that went wrong? And, you just keep building on that, especially if you're new to welding. Figure out what you're doing right, continue to do that, find out where your downfalls are, and improve in those areas. I always tell students, put 3 welds down and see what you're doing right or wrong consistently, and then adjust from there. And I picked that up from my days in the military. Whenever we were sighting in a rifle, we always had to make 3 shots just to make sure that there wasn't a fluke. So if you can do 3 welds consistently, and it doesn't mean if it's consistently good or consistently bad, it doesn't matter. I want to find out what part of the current length of the arc, the angle of electrode, the manipulation, or the speed is going wrong. So put 3 passes down, find out what's going wrong, and then fix those issues. All right. Moving on to equipment setup. Whenever we get out there on the job site or in the shop, we're going to go through the machine. I want to make sure you're going to select the right polarity for, the rod that we're using. Like I said, not all rods are going to run on DC electrode positive. Majority of them are, but some of them are going to run DC negative. So we want to make sure that we select that right polarity for the rod that we're going to be using. And you should be able to tell the difference between negative and positive. When I start teaching easy for you to say, when I start teaching shielded metal arc welding to my students, I let them weld for the first couple of days on reverse polarity right where they're supposed to be. And then on that 3rd or 4th day, I'll say, okay, so from now until lunchtime, I want you all to weld on straight polarity using a 7018. You shouldn't be welding on straight polarity with 7018, right? So I want them to be able to hear the difference, to see the difference, and feel the difference. That way, if they hook it up by mistake, they understand, oh, damn, it's troubleshooting right there. If you know what it looks like, sounds like, and feels like, you know exactly what the problem is. You can go back there and switch your polarity. Next thing is amperage. We want to make sure we dial our amperage in, just like I told you before. Check your consumables book, check the welding procedure specification, or if you're a seasoned pro, you know what it's supposed to look like, sound like, and feel like. Strike up on a piece of scrap material. If I'm getting ready to weld on something and I want to dial my machine in, especially for those of you that work with companies that have 2nd and 3rd shift and you're not the only person using that welding machine, I'm not just going to go over there and flip the machine on, throw a stick in the stinger and start welding, right? I'm going to go over there, I'm going to grab a piece of scrap metal that's very similar to the thickness and joint configuration that I'm going to be welding out, and I'm going to strike an arc and I'm going to run a bead. I'm going to make sure that everything's set up correctly. Another thing I like to adjust is my arc force and hot start. So arc force is it's a nice to have. Not all machines have them, but if you do have arc force, I highly recommend that you use this. What this is going to do is going to help prevent you from sticking. Okay. So depending on the machine manufacturer, you're going to have to play with them for a little bit. I know on my Everlast at home, I like about 10% arc force. Whereas with the Lincolns that I use at the school, I'm running about 35% arc force. The ISOTUNES Rebels that I've used in the past, roughly 20-25% arc force. Now, these are all settings for 7018. If I run a 6010 or anything like that, I'm probably going to go above 50%. But what arc force essentially is, it's a temporary increase in the output current during the welding process when the arc is too short. So that means as I get closer, amperage is going to bump up and it's going to prevent me from sticking. But it's also going to dig in a little bit deeper because now I have that increase of amperage on my side. I'm going to dig in a little bit deeper. So you don't want to crank it up too high because with a 7018 electrode, that could lead to undercut. You're going to get a lot of weld spatter and stuff in there. So it's basically a fine-tuned adjustment knob. So if you want a nice smooth arc with less spatter, you want to set your arc force, to the minimum side. Like I said, 35% or lower. But if I want a more crisp arc with more penetration, a little bit more digging action, a little bit more aggressive, I'm probably going to bump that up above 50%. So if I'm running a 60-10 or something like that, trying to put a root pass in, I'm going to bump that up. That way I make sure it's burning in really nice. So adjust your arc force and then play around with it. Like I said, every machine runs a little bit different. So take the time, run some test pieces, run some practice pieces at the house or the shop, play around with that. The next thing I like to adjust is my hot start. Hot start, once again, it's a temporary increase in power. Now, most machines are going to be preset at like a half a second of hot start. So if you have a hot start feature on there, you're probably not going to be able to adjust the duration. I know with some of the Everlast models and some of the ESAB models, you can crank it up to almost 10 seconds. So essentially what that is, let's say I'm running at 100 amps and I set my hot start to 20%. So as soon as I strike that arc, I'm going to hit roughly 120 amps for a half a second. Or if I have it set up for 5 seconds at 20%, I'm going to strike it and I'm going to hit that 120 amps for 5 seconds, or whatever the duration you have set at. So it's just a momentary increase in amperage to help start. So if you're lighting up on a cold piece of material, room temperature, you might want to bump that up because you don't have any heat in that plate. So if I strike that up, I'm probably going to get like a high spot right there at the initial point of contact, which I want a nice smooth weld profile the whole way through. I don't want cold lap. I want to make sure I tie into both edges nice and smooth. So bump up that hot start, for a short amount of time. Once you get some heat in that plate, you can bump that hot start down just a little bit, whether it's the percentage of hot start you're using or the duration that you're running it for, because I've already got heat in that plate. So if I'm going to do a restart somewhere in that area, I might bump that hot start down just a little bit because I already have heat built up into that plate. Last thing I want to talk about once again is voltage. So remember, as I increase my arc length, voltage is going to increase. I'm going to get excessive spatter. My amperage is going to drop slightly. So now I don't have the amperage that I set on my machine. The puddle is going to be really wide if I'm out of position, especially in overhead. Now I've got molten metal falling on me. So you want to make sure you keep it nice and tight. As the arc length decreases, the voltage is going to decrease, but my amperage is going to increase. I'm going to get closer to what I set my machine at. So you want to make sure that you maintain a nice tight arc length the entire time throughout the piece. That's pretty much all I have for fundamentals of shielded metal arc welding. What I would like to do in the next episode of this is, kind of break down the different electrodes that are available. So go through, 70-18s, 60-10s, 60-13s, 80-24s, just kind of break that down, talking about different polarities, flux compositions, diameters, and different uses and applications for the different types of electrodes that are out there. Because that's the coolest thing about shielded metal arc welding or stick welding is based on the application, I can just change my electrode. So if I'm welding on something really thin, I can switch over to a different electrode and completely change it. If I have dirty, contaminated, rusty material, there's a specific electrode made for that. If I have nice, clean material and I'm doing some structural stuff and it's very critical, there's a rod for that, right? So next episode, I want to break it down into the different types of electrodes, different polarity settings, when we're going to change our polarity, and then different techniques. So I hope you guys enjoyed this episode. That pretty much concludes it. I thank you guys so much for the download. If you have any questions, comments, concerns, you can always hit me up on Instagram at ArcJunkiespodcast. You can email me directly, show@arcjunkies.com. I appreciate everybody listening. Don't forget to swing by the Arc Junkies website, arcjunkies.com. Click on the merch tab for all the Arc Junkies hats, shirts, sweaters, hoodies, all that good stuff. I hope to see a lot of you all at FabTech. I'm going to be giving out slap packs while I'm there, doing some stuff with AWS. I'm going to be touring the show. I'm going to be doing a little bit of portable recording, talking to different vendors, talking to different people from Instagram, different friends and stuff. So stay tuned for that. I'm probably going to have a lot of content once I get back from FabTech. Appreciate you all listening. And until next time, make every weld better than your last.